Today is 4.1b. We are going to extend our knowledge of confidence intervals, and then at the end you're going to be doing your own survey and building your own confidence interval. Oh, you should say yes, yay! But this will be good because you're going to get some dirt on your friends and your parents that you can hold over their heads if they answer correctly. All right. So up until now, which means the last worksheet, we use the Rossmann chance applications to calculate our confidence intervals. And some of you realize that there's actually a button, and you just click confidence interval, it spits out the answers for you with very, very little work. So I'm going to show you how to do the confidence intervals by hand. They're actually super easy, and it's going to make a ton of sense. So tear off the back page, and once again, I don't have answers for this because I wrote it today, but this table is a normal curve z-score area table. So I want to explain how this works. So if we have a normal curve, and in the center we're going to put 0. Okay? And then the distance here is going to be 1 and -1. And if we graph the standard normal curve with z-scores, we know that between here and here is 68% of the population or the sample or whatever it is you're looking at. So looking at our table, we have a column of z's, and then we have the area. That area is how much of the population is between z and -z. So how much is in there? So if we look at 1, if we go right 1 and left 1, then that captures 68.3. I've been lying to you all these months. 68.3%. Okay? So how much is between 2 and -2? Well, we always said it was 95%, right? So we're going to go to 2, and we see, oh, I lied to you again, 95.4. I know, I'm a liar. Okay, and then for 3, we always said 3 was 99.7. So you can actually use this table to find out all sorts of areas. For instance, how much is between 1.6 and -1.6? So we go to 1.6, and I get 89%. Okay? How much would be between 0 and 2.5? From 0 to 2.5. So we're going to go to 2.5, and I get 98.8, and then I divide that by 2, because this area here is half of the 2 to -2. So this table tells you central area. Okay? If I said 40% of people are between these two z values, what z value would that be? It would be from +0.52 to -0.52. So the z table actually goes in both directions if you need it to. Does everybody understand that? So that's what we're going to use to build our confidence intervals. All right. In my 1050 class last period, I had a question written up. It was about people who had cancer. It was depressing. I didn't like it. So I asked my 1050 kids, what questions should we ask in my stats class? And it needs to be something ridiculous. And this is what they came up with. Suppose you want to know what percentage of people in this country ate their boogers as a child. I totally approve. It's 100%, right? Yeah, we're subject to recall bias and response bias, whatever. That's fine. So a simple random sample asks 320 people, and 208 admit they ate their boogers as a child. The rest of them just couldn't say yes. Right, Taylin?
I'm going to say I can't remember.
No, David, I know you ate your boogers, for sure, 100%. Okay. So, using your calculators, what percentage responded yes? 65%. Okay. So, we need to calculate the standard deviation of this so that we can calculate z-scores. But this was just a yes-no question. So, how do we find the standard deviation for categorical data? Well, we use the formula, and I've given it to you. The percentage of successes times the percentage of failures divided by the number of people you talk to. So what is my percentage of success? 65% of people were successful. Right? So 0.65 times, what's the percent of failure? 0.35. And we divide that by the number of people we talked to, which was 320. So I get a standard deviation. Is this a sigma or an S? So is this population or sample? This is sample, so it's S. So S is 0.0266. Okay? All right. So number 3 says, use the z-score chart to determine what the z-score, what should just say what z-scores would encompass 95% of our sample. So looking here, 95% is actually, where is it? 1.96, not 2. 1.96. So we wanted to find what z-score gives a central area of 95%. And it ends up being 1.96. Okay. So going back here, I need to build a confidence interval. What is the center of my confidence interval? 0.65, right? So my sample yielded 65%. So if I had to guess what the true percentage is, my best guess is 65%. Everybody see that? But I want to draw a window around that that encompasses a 95% confidence interval. So I'm going to add to this not two standard deviations, 1.96 standard deviations to the right, and I'm going to subtract 1.96 standard deviations to the left. Do you guys get that? So my standard deviation is 0.0266. I'm going to multiply this by 1.96. Now, in the future, if you do 2, that'll be good enough for 95. Okay? So I'm going to take my standard deviation and times it by 1.96. Now what do I do with that? So 0.65 plus the answer, and 0.65 minus 0.05226. And I get a confidence interval from 59.8% to 70.2%. And you can't just report this. You have to say the 95% confidence interval is 59.8 to 70.2. Where did you get stuck? So my center is 65%. I need to go right 2 SDs, and I need to go left 2 SDs. And that will create a window. Yeah, we did this in the last assignment. And so how far is it going to be from here to here? It's going to be 2 of those. And it's actually 1.96. So my standard deviation times 1.96 is 5.2. So I need to go right 5.2, and I need to go left 5.2. So 65 plus 5.2 is 70.2, and 65 minus 5.2 is 59.8. Why? Oh, sorry. It is this. So I know if I draw a curve and I put 95% in the middle, how far is this? It's 1.96, or 2 SDs, 2 standard deviations. So I need to go right 2, and I need to go left 2. Well, how far is 1 standard deviation? It's 2.66%. So this is 1 standard deviation. So I need to do 2 of those to the right and 2 of these to the left. We're going to do a whole bunch of them, so hopefully it'll sink in here in a second. Why do I need to list this in my answer? There are different confidence levels. If you want a wider level, what do you do with your confidence? So if you want your interval to be super wide, you're just going to raise the confidence, right? Like I'm 99.99999% sure that the true interval is somewhere, or the true value is somewhere between 0 and 100. That's not useful, right? Actually, that's 100%. What if I said I'm 10% confident it's somewhere between 65.001 and 64.999? That's useless, right? You're probably wrong. Okay. Everybody kind of had a handle on that? No? Yeah. Okay, we'll do some more in just a second. But question. Okay, so that was 4. Number 5. How accurate is this confidence interval? 95%? No. The true answer is we don't know. But it's either 0% accurate or 100% accurate. Why? Is there a true value of booger eaters? There is a true percentage out there somewhere. Will we ever know it? No. Why not? It's 100. So why won't we ever know? There are a lot of things working against us. First of all, there's too many people to talk to. But there are other problems. Some people refuse to answer. Some people lie. So even if we talked to everybody, we probably, nobody's pointing fingers at you, David. We will never know what the true value is. So why do we call it a 95% confidence interval though, then? What does the 95% have to do with this? Right. Before we take a survey, this process will be correct 95% of the time. And what that means is, this is the true value, and it's unknown. I build a confidence interval. Did I capture the true confidence interval? In that case, I did. And maybe the next person gets that, and the next person gets that, and the next person gets that. If 100 people do this, 5 of them will create an interval that's wrong. So we call it a 95% confidence interval, not because our particular survey has a 95% chance of being correct, but the process will be right 95% of the time, meaning 1 in 20 will be wrong. So it's entirely likely that you go through this whole process And you build a confidence interval only to be wrong. The nice thing is, you'll never know. Okay? All right, so let's go back here. So 65% was my center. That was the center. My standard deviation was 2.66. Okay, and when z, or sorry, let's go back. A 95% window is z equals plus or minus 1.96. Okay, where are you stuck? It was, oh. Is that better? You were right. No, you, no wonder you were confused because I was doing it wrong. Okay, so number 6 says, create an 80%. So how far away do we have to go from the center to capture 80%? So we go here, and we find 0.8, which is, where did my, this is weird. Did I move that to another page? Oh. Okay, so 80%, we're just going to have to use 1.28. So see if this makes sense. If I want to create 80%, how far to the right do I travel? 1.28. That's my z-score. Or, and out to negative 1.28. All right. So, my confidence interval is going to be 65% plus or minus what? 2.66% times 1.28. So on this graph, I go right 1.28 and left 1.28. But that's in terms of standard deviations. How big is each standard deviation? 2.66%. So I open up my calculator. So 65 plus 2.66 times 1.28 and 65 minus 2.66 times 1.28. So my confidence interval is 61.6 to 68.4. Does that make sense, Taylin? So why is this confidence interval more narrow? My confidence level went down. Am I 80% sure that this is that the true value is in this window? No. This answer is either right 0 or 100% or it is wrong 0%. But the process will be right 80% of the time. Okay? Now, why do we choose a 95% confidence interval? Somebody just randomly picked it. And what you'll see is either a 95 or a 99 or a 99.7. Those are sort of the three that are super common. 95 is by far the most common. 99 is used a lot of the time, and then some that are higher are used much less. I believe all medical tests have to be 99.9. No, just 99.9. All right. So the next question asks, how about a 90% confidence interval? So I'm going to go to my table, find 90%. And it's 1.64, yes.
So like on the bottom it says it kills 99.9% of germs.
Is that a confidence interval? The antibacterial? No, I don't think it is. I don't think it's a confidence interval. They can't put 100% because if you use it and you get sick and die, they're like, I told you, 99.9. But they're not giving you an interval. They're just giving you the expected value. Okay, so 90% is 1.64. Let's get rid of this. So I need to do 65 plus 2.66 times 1.64. And then the same thing with a minus. So from 60.6 to 69.4. Okay. So you need to finish part A and then look at part B. Suppose a second sample yields 202 successes out of a total of 330. You're going to go through the same set of questions. Okay? And then go to the back. Part C. This is going to be tough. Determine whether each of the following is true or false. Okay? So I'm not going to answer any of these, but I want to go through some different options. Okay? So let's say this is my window, and it's a 95% window. If I change it to a 96% window, what's going to happen to my interval? It's going to get wider. To be more sure, I need to cover more area. Okay? What if I increase the number of people in my sample? What's going to happen to my interval? It's going to shrink. Why? Because the standard deviation is divided by n, so the standard deviation gets smaller, which means your interval is going to shrink. And you can also think of it as the more people you talk to, the more accurate your survey is going to be. So if you add people to a survey, the window is going to get smaller. Okay. If two surveys have the same number of people, but they have different percentages, and they both do a 95%, which one is going to be wider? So let's say one is 16% and one is 10%. Which one is going to be wider? Well, it's going to come down to the standard deviation. Oh, Allison's doing it. The square root of 0.1 times 0.9 is 0.3, and the square root of 0.16 times 0.84 is 0.36. So a longer standard deviation will have what effect on your confidence interval? Standard deviation is bigger, and you take the standard deviation and you multiply it by the z-score, so it's going to be wider. So the 16% is going to have a wider interval than the 10%. Okay, then 27 through 30, you just have some questions to answer. I'll have all these answers done by tomorrow, so we can talk about them. Okay, part E. It's now time to complete your own survey. Ask at least 75 people, none of whom could be in this room, other than yourself, if they ate their boogers as a child. Okay? Oh, totally. Totally. It's just a yes or no. Just say your stats teacher said you'd fail if you don't do it. So, you need to record at least 75 responses. No, you got to ask this question. It's way more fun. Oh, what? Okay, let's do a survey. How many of you ate their boogers when they were a kid? My hand's in the air, by the way.
Yeah, everyone.
Oh, come on. Come on. How many of you still eat your boogers? No, let's not ask that question.
Oh,
Okay.
we're not answering that?
So, you have my permission to pull out your phones and start asking those questions. And then as the responses come in, you can work on this. We will go over every answer tomorrow. Got it? Okay, get to work.